In the last video, we saw that vectors could be represented in different ways. And unit vectors is representing vectors with ijk, where ijk are unit vectors along x, y, and z axis respectively. So in 3 space, we can represent any vector using ijk. So let me just sketch here our coordinate system in 3 space, which will be like this. Now we are saying that I is a unit vector along x-axis and j is a unit vector along y-axis and k is a unit vector along z-axis. Now these unit vectors are always perpendicular to one another, right? Because you can see the axes are also perpendicular to one another. And in R3, we can represent any vector using combination of these. That is, as a linear combination of these. So this is what helps us to represent a vector in R3. So let's summarize this. Vectors ijk are unit vectors along x, y, and z axis. They form standard bases in R3. When we say they form standard bases in R3, that means any vector whatsoever in R3 can be written as linear combination of ijk. A vector u can be specified as a sum of scalar multiples of the components of vectors ijk. That is what we mean when we really say that they form standard bases in R3. So we'll prove it with the help of an example. Let's say we have a vector u which is 2, minus 5, 3. Now we need to represent this as in unit vector notation. So what does it mean? It really means that we have 2 along x-axis, right? When we say 2, minus 5, 3, these are our direction numbers. So if you have to draw this vector or see the position of this vector in R3, then how are we going to go about? Basically, 2 is a direction number along x-axis. So it is like this is 1, then 2 will be like this, correct? Now, since that is 2 units along x-axis, we could write this as 2i, right? So I can write this as 2i. Do you understand? 2 times unit vector I. Now let's look into the next one, which is minus 5 along y-axis. That means we will go in this direction, correct? So let's say this is minus 5 along y-axis up to here, right? Now since j is a unit vector in positive y direction, minus j will be the vector or the direction along minus y, and therefore I can write this as minus 5j, correct? Now 3 is along z-axis, 3 units. So there you go, 1, 2, 3. So there you are. So that is the final position of the vector u. So that direction is along k vector, and the magnitude is 3 times k. That is what we mean by doing scalar multiple, right? So we can write this as plus 3k. Now the vector for us will be tail at origin and head at the final point, which is this vector. So this is the vector u for us. Do you see that? Now vector u is 2i, and we'll write this as minus 5j plus 3k. Do you see that? So that is how we can represent any vector in R3 using our unit vectors ijk. So we say represent vector u. Whenever it is bold, it is vector. So represent u equals to 2 minus 5, 3. So that is a position vector u as linear combination of unit vectors. So that is a linear combination. You see that this plus that, and all these three components have been in the direction of I, j, k. So that is how we can translate, or we can represent a vector given in ordered triple as a unit vector notation. You can see here, right? So that is the way it should be done. So we could represent our vectors as ordered triple or as unit vectors. But whenever we are doing so, basically it is linear combination of unit vectors that gives us the equivalent representation of the vector. Thank you.